Now, if you want to explain the motion, then first of all, we have to locate the position of the particle, and if the particle is continuously changing its positions with time, then we say it is in motion. So if particle is changing its position, then we have to think about displacement and path length. So now in vector form, how one can locate the position of the particle, and with the help of change in positions, how we can think about displacement. So let's understand this thing. Okay. Now here we already discussed this thing. We consider the Cartesian coordinate system, or we can say rectangular coordinate system, as a frame of reference. Suppose a particle is moving in the xy plane, and the particle moves on this curved path PQR. And here arbitrarily we consider this thing at some instant t1, particle is at position P, at some instant t2, particle is at position Q, and at some instant t3, particle is at position R. Okay. Now, in vector form, how one can represent these positions? And when in vector form we represent these positions, then it is called position vector. It is called position vector of the particle. Say, suppose particle is at point P. Then here the frame of reference is Cartesian coordinate system. So reference point, that is the origin. When we think about the vectors at that time, reference point, that is very important. Now, here prepare a vector joining to origin O and point P, and say this particular vector is R1. Say it is R1. Then here we can say this thing, vector OP, this vector, its name, or we can say it is symbolized as vector R1. Then we can say that is the position vector of particle at time t1. Now at some time t2, your particle is at point Q. Then prepare another vector joining to O and Q. O and Q. Okay. So now say this vector is vector R2. Then the vector OQ, that is vector R2, then we can say this vector R2 is the position vector of a particle at some time t2. Then after, at some instant t3, particle is at point R. Again here prepare third vector joining to O and R. Say that vector is vector R3, then we can say vector OR, that is vector R3, and that is the position vector of a particle at some time t3. Clear to all of you? So in this way one can represent the position vector of particle at any time. Now let's discuss the displacement vector. See, as per definition, displacement, that is final position minus initial position. So here, see, prepare a vector joining to point P and Q. So this vector PQ, here represented by red colored vector, this one, right? At time T1 particle is at P, at time T2 particle is at Q. So we can say now displacement in time interval T2 minus T1, that is vector PQ. So in other words, we can say PQ is the displacement vector in the time interval T2 minus T1. Suppose we think about the vector joining to P and R. P is the position at time T1. R is the position at time T3. So now we can say this thing, displacement in time interval T3 minus T1, that is vector PR. But see, very important thing here again, which we already studied in chapter number 3. Your displacement vector is not coinciding with this actual path of the particle. It implies that displacement, that is nothing but the shortest distance between final and initial position, and this curved path, that is the actual path traveled by the particle. So here again you can understand this thing, the magnitude of the displacement, that is always less than or equal to path length. Magnitude means value. એટલે કે જો ધારો કે આપણે અહીંથી અહીં સુધી P થી R સુધી ખાલી ડિસ્ટન્સ માપી લઈએ, માનો કે એ 5 સેન્ટીમીટર થયું, તો હવે તમે એક્ઝેક્ટ આ બ્લેક લાઈન જે છે કે જે એકચ્યુઅલી પાથ છે પાર્ટિકલનો, તો આ બ્લેક લાઈન ઉપર લાઈન ટુ લાઈન, લાઈન ટુ લાઈન, લાઈન ટુ લાઈન, લાઈન ટુ લાઈન, અહીં સુધીનું ડિસ્ટન્સ મેઝર કરો. એટલે આપણે લાઈન ટુ લાઈન એક દોરી ગોઠવી દઈએ, આપણે થ્રેડ એવો કર્વ જે હોય તો એક્ઝેક્ટલી એને કોઇન્સાઇડ થાય એ રીતે, અને પછી એને પકડીને આપણે સ્ટ્રેટ કરીને સ્કેલ ઉપર મૂકીને લેન્થ એની મેઝર કરી લઈએ, તો એકચ્યુઅલ ડિસ્ટન્સ ટ્રાવેલ્ડ આટલું હતું એ મળી જાય આપણને. Then we can see this thing, magnitude of displacement is always less than or equal to path length. So now clear to all of you what is position vector and what is